Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on Tim, which is my titanium virtual machine. It's a virtual machine similar to like the Java virtual machine, if you're familiar with that. Alright, so let's take a look at what we've got thus far, and then talk about where we're going today. So let's see. So I built everything. And yes, we have these here. These are the executables. And then we have a couple files in here for like testing and such. So let's see. What is like a good showcase? How about the hello world? So I'll just copy and paste the hello world to the build folder, and then let's compile it. And then what? I think I have to do that. There's a few issues which I'll probably work on today. Maybe not. It was working yesterday. I don't know what happened. So, oh shoot, I was doing the wrong file. That's my bad. Find that file. Yes, we don't have the standard def, so I can just replace this with native one. That's just like a macro basically that we have. Yeah, and then I figured it is. Okay, let's try this again. Yeah, we don't have that, so that has to be one as well. Macros. Okay. And then hello world.tim compiles to a binary file, which we can actually take a look at. So this is the bytecode of the virtual machine. So we have a few things in here. You can see the string that we put there. We also have the size of the string. Yeah, and then a couple other things here. This is like the instructions and things like that. So let's see if we exit out of that. We can now try to execute it. And hello world, we get that. So yeah, this is what it looks like basically. So you push string, and what this will do is it will allocate space and memory, this size, the size of the string, and it will fill in all of the components or all of the slots in the memory with the corresponding characters, like an array essentially. And then it will push the pointer to the start of it on the top of the stack. And then we push 1, that is for standard out. And then we call native 1, which is the write syscall. So we'll pop this from the stack. Yo, what's up? Stam, how you doing? Yeah, so it'll pop this from the stack, and that is the file descriptor that it's going to output to. And then it's also gonna take the pointer, and it pops it off. And then it just writes it essentially to standard out. And then this entry point main, that is just the entry point, right? So it's like a main function, that kind of thing. It's pretty simple, pretty simple. So, we've been working on implementing memory. So the way that works is basically you have memory, and I don't remember exactly the exact order thing, so I'll have to look in here because I just started working on it. So, it's in this one. Let's look at memory, and we'll take a look at that. So, int, and then another int. Okay. What is it? Okay, so the int is that is the amount of memory to allocate essentially. Yeah, and it will just allocate that amount of memory. So you have to push to the stack, so you can push say 32, right? If you want to allocate that amount. And then you call memory. We don't have highlighting for it yet, but that's okay. Yeah, and we'll just allocate that. And then it pushes the index right now. I'm gonna probably change it today so that it pushes an actual pointer, because that'd be more useful. And then we can do different stuff to it. So we could write to the memory with this, right? So you can the index, this is what is the index for? Data. Okay, so we have the data. Yeah, where do we use index? I don't know. Hang on. I don't remember what that's for. Do I even use that? Let's see. I don't see it in here. So what's the point of it? I don't quite get it. So I comment this whole thing out, and then recompile. Sorry, I'm learning things. Let's try to build it again. Yeah, we did get no issue, so I don't know what the point of it was. So I'll just leave that commented out. I don't remember what I was using that for. That's kind of fun. Okay, so we pop the data. So this is basically the different type. So I'm going to change it actually so that you push the size, the amount, the size that you want to write to. But for now, you push that so it can be either a character, an int, and all of these are 8 bytes. Yeah. So that's how that works. And you write to it essentially. Pretty simple. And then the pointer is basically the index in the memory. So that's how all that works. So that's what we're working on. We also need a way to deallocate memory, right? So remove something from the memory. So if you have the pointer to it, and then you have the size. Well, actually, do you want the size? Because I don't know how that would work exactly. I guess you'd have to pass the size. I'm not sure. I'll think about it. Basically, then it would remove it from memory, and the memory, I can take a look at that as well. That's in here. Yeah, right here. So you have the memory, and basically it's just a dynamic array. The highlighting's a little wonky. Don't worry about that. Basically, this is memory, right? So it's an array. So we'll have to shift the array left by that amount. Yeah, because we'll have the extra stuff there. So we'll have to do that. Yeah. So then it'll basically free the memory, and it might be a little slow, but it shouldn't be too bad unless you have very large things that you're freeing at once. So that is sort of the plan for today. A few things like that. So, first of all, I'm going to change the memory. So, let's see. We do this in like this. Yeah, and so I wanted to push a pointer instead. As pointer. And then you can decide like what the type is and all that stuff on your own. So we don't want this. We want the pointer to this in memory. So machine memory dot data this. So that's gonna be yeah, that's gonna be the pointer to the start of the memory, and we push it as a pointer type. Yeah, and then when you pop it on, so we're gonna have to change some stuff where we do that. So like with the write instruction. It pops off and expects an integer, so we want to now expect a pointer. And then we also want, I won't actually change that yet. So then we want this, it's gonna have to be different. Basically we can just do the pointer, right? From that point. There's just a pointer to that, so that should be fine. That as pointer. And actually, I could even do this, you know? I can make this a void pointer. And then I could just pop that dot as pointer. Actually, I shouldn't do that probably because of that. So maybe pointer data, right? Pointer data. So we can check that, and then we can actually set a void pointer. So this will be the actual pointer equals pointer data dot void dot as pointer. Yeah, so we can do that, and then we don't have to do all this stuff. We can just put pointer. So the pointer, and then we'll write that amount. So yeah, the amount is this for now. So I'll make it u. The amount will be on the stack. So we'll get to that. All right, so this can just be pointer as well, and that should write to it. And then we have to modify the read instruction as well. Pointer, okay. Alright, and that was the last one, so we're good there. Alright. So let's look at the read instructions. What do we have to do here? So yeah, it functions the same way where you have these different things. The pointer now needs to be an actual pointer. Whoops. Pointer type. Is that how it looks, or is it? What did I do up here? I don't remember. I guess pointer type. So I'm gonna assume that's right, but we'll get a compiler, so that's fine. This will be pointer data, right? And then we'll set void pointer equals pointer data dot as pointer. There we go. So it might not actually like me copying into it since it is a. Yo, what's up? How you doing? Shit. So this just needs to be pointer. Corner of God, yes. Pointer. There we go. Yeah, we'll just read the data from the pointer. How goes? It goes well. Goes quite well. How goes with you? Alright, yeah, there might be some issues because this is a void pointer, so we might have to cast it or something of the sort. Okay, so we can do that, and let's go here and try to build it, and let's see what errors we get. Okay, so pointer type, yeah, so I think it is PTR type. So let's go here, whoops, I went past it. PTR, okay. PTR type. Whoops, build that. build.sh, there we go. Okay. Oh shoot, so that, I also think that's that. So, there's an issue there, this needs to be PTR type as well. There we go. There we go. Work. Let's see. PTR undeclared. Okay, so I guess I did not declare that. Oh yes, identity.word.export. So that's 557. Yes, this needs to be pointer data. And then this needs to be pointer data.word. Pointer. And that should be it, I think. Yeah, okay, so it compiles now. So let's see what we got. Yeah, so now I guess I should test it to make sure it works. So let's try to write something and then read it. So we can allocate some memory. Go here. So I'll just modify this file, sure. Let's get rid of some of this stuff. Oops. So I'll leave that each one time. So basically memory. So we'll push let's allocate 8 bytes. Call memory. So that's gonna allocate it. And then let's see. So what's the order of this? I don't remember exactly. There we go. Okay, so to write, we need to push the data. So the data, yes, that's the type. So let's write an integer, right? A 64-bit integer. So we'll push we will push 2 there. I guess 1. Yes, we'll push 1 there. And then we need the pointer. So we will just let's do the pointer. So we'll have that. Then we'll push 2. So and then we can call write. So that should write enough space for an integer essentially. Wait. No, the data that it pops. Oh yeah, so we need to push the data that the type comes from that. So yeah, we're gonna push an integer here. So let's do just something like that. Pointer data, so that'll pop that, and it'll be a pointer. And then yeah, then we need to call read, and that will push it to the top of the stack. So we had to duplicate it because this is going to consume it. So we'll just have it'll be on the top now, the unduplicated one. We don't have to duplicate it this time. Okay, so the type, yeah, so that is just we need to push 1, right? Push 0, I guess. So int is there. Alright, that's a weird order, but okay. And then the pointer. So yeah, the first we'll push 0. And we'll call read. Okay, read. And that should be all that we need, I think. And then we'll copy it in the data and we'll push it there. So then we'll print what is on the top. So if all goes well, we'll be able to compile that. And we got that. So it seems to have written properly. So if I go ahead and duplicate it before we do this, then I can push 0 again and call read. And the print, and there should be 2 of them that were read from the memory. Nope, so I'm messing up. Let's see. Oops, what happened there? Okay, so let's see. I probably put it in the wrong spot. So do push 0, read. Oh shoot, yeah, because now it is not in the right order. So we need to swap, I think. 0, and then yeah, so that should be the right order. Okay, yeah, so it is writing and reading to the memory properly. So that is very good too. Let's get rid of this. Or let's leave it actually. And we're gonna change it. So instead of pushing this, you're gonna push the size of what you're doing, right? Instead of this, because this sort of infers the size based on the type. That's not exactly what I would like to do. Okay, so yeah, instead of this, we're going to this is gonna be size, right? Size what will be on the top. And I will just break here, so I don't need to worry about getting rid of this yet. Yeah, okay, so we are going to write to it this amount. Okay. So data, oh shoot, we still need the data. Yeah, so we need the data that you're gonna write in the size. Let's love the data, but then we will have the size off the chain, and then if we'll need to check this thing for the size as well. Size.type is not equal int type. Then we got an issue. This needs to be expected pointer, not int. Okay. So we copy the pointer. Data.word. We can just copy the word. I think that is fine. Into the data. So you'll have to know what the type is yourself. Okay, and then amount, so we don't need amount. Instead, we're going to do size. Size.as. So we probably check if size is less than 0, then call this print error as well. There we go. What is that about? Does this have that? Yeah. Okay, I need to look into that. Let's see. Error. Size cannot be negative. There we go. Okay. And then we'll write to it based on the size. And then we need to push it. No, we don't need to push it. That's in the read. Okay, so that should be good for that. And then we can modify the read. So, yeah, you're going to push the size. So let's do, is the size going to go first? Well, no, so we're going to replace type with size. Int type size still all good. And then we have to check if, size. Size.type, no, dot, word dot as int is less than 0, and we can print an error here. Size cannot be less than 0. No, cannot be negative. There we go. Okay. And then, yeah, then we just copy that. So we don't know the type of it, so you'll have to cast it yourself, I suppose. And we'll just make it a pointer. So we'll need something to convert, to cast a pointer. No, we'll push it as an int. Or just maybe a vague type. I don't know, I have to think. I'm not sure. But we'll pass it data. We're going as int. Alright, so we'll read this. I think this, yeah, so we were setting the type there, so we don't know what the type is in this case. Copy the pointer into there based on the size. That might be too much as well. But we'll try that, and then we push it. We don't have the type, and also we don't have data, so data.type equals okay. I don't know. Like, what's I guess just a type. Can we interpret it as that, or should we make it maybe a pointer type? I'm not sure. Try that. Okay, and we'll see how that goes, and then we'll break here. Let's see if it can compile here. Okay. Yeah, that needs to be. What was the index there? 524. It needs to be size.load.everything. Then we have same thing. 532. Okay. Again, amount undeclared, so I need to get rid of it. Okay. Yeah, so we just have amount in here, we can just get rid of this. I'll probably get rid of the whole thing, because I'm not going to use it anymore, so get rid of that, there we go. And then alright, size, we need to do size.as int. Oops. 549. Okay. Size.word.everything. And then I'm gonna have to get rid of this because we don't have type anymore. We can just get rid of all that. Okay, so now it compiles. So let's modify the program. So we need to modify this. So the memory can stay the same, and we can still duplicate the pointer. So this is the data that we're gonna write. Let's see, what is the? I feel like the size should be first. I think that makes sense. So size is not first here, so let's change that because I would rather have it first. Okay, so I will just build, and we will modify this. Okay. Push that, and then we push the size. So we want to 8 bytes because it's an integer, 64-bit integer. So we'll push 8, and then we'll write to the memory. Then we have to duplicate the pointer again. Push 0. So we don't want 0 there. We want the amount of bytes to read. So we'll do 8. We'll read it. And let's see. Swap. We have to do that. Oh yeah, because we're reading twice. And we'll push 8, and we'll read, and we'll print them both. So it should still be able to print them, but we can't really do a lot with it because we don't know what the actual type is. Okay, so we do get that, but the type is kind of ambiguous, so it's treated as an integer. I think it will still work if we do something like this. It's still 64-bit, so yeah, we still get the proper float. But it's considered an integer, so we'll probably need to well, so it's integer by default, so I'll have to cast a float. Let me look at how I have that. So I do have some stuff. So I have like inst, yeah, float to int. So we just cast it like that. What if we don't have this? Does it still work? Because then we could make it more general, you know? Alright, let me, okay, so I'll just make a s.chasm. I don't need any joint for it, so we'll just push, you know, something like that. A float, and then we'll call float, and then we'll print it. Let's save that, and let's compile it. I think I did it right. Unloadable. Okay, yeah. That's not Tim. Okay, as in. Okay, yeah, so it did cast it properly. So I think we can make it more general. This can just be inst. I don't really want to rename it, because then I'll rename it. Alright, so this will be to float. Yeah, I can just be that. And then this can be, okay, int to float. No, so this is to int. So this just converts it to an int, right? To int. Boy. And then this can be to f. So we can get rid of the as in. Whoops, that was not right. There we go. Okay, and just push it as a float type, so that should be fine. So I do need to modify that, but let me make another one for to pointer, right? So to BP void. Yeah, so just interpret it as a void pointer, and we'll pass it as a pointer type. So I think that'll work. Yeah, so then you can do stuff based on that. And then maybe the character as well. Well, I'll just make one. Whoops, not that place. This will be to character top. Just a character. There we go. And I think that's all the types that we have right now, so that should be good. So I need all these instructions. Let me copy them so I can remember. And I can rename them in here. Let's see. So we have all the way down here, I think. Yeah. So to float, to in. It's to, is that the right order? To float, to in. Yeah. So to VP, and then it's to yeah. Okay. Now I need to modify it in the Lexer, so I need to add. It's actually not there. It's in here. I need to add the keywords, right? So change this. So pop toy. And then let's see, toy to VP, and then to there. All right, so that's all of them. And then we need to modify the. Let's see. I think we need to do. Do we have anything in here? No. Okay, so we don't. So I think we just need to modify the actual one here, and we just need to add them to this. So we have a couple instructions here. Where is the right here? So we need to convert this to just that. Inst to VP and inst to there. Alright, so that should be it. So it should compile. It's gonna break a lot of stuff, that's okay. Let's see, so it's all in .c, so we can do that. Right, so where is it at? So 773. 773G. Yeah, so I need to modify this. As pointer, and then as character. That's what the issue is. Okay, so let's go there. Okay, and this is supposed to be a semicolon. or a regular color, not a symbol. Okay, so what is this? We're a floating point or an integer. Uh-huh. So that doesn't work. So what if I make like a pointer, right? So pointer equals void star a dot word. Does that work? And then pointer. We need to cast it to word though. Like that. It expects to work. Alright, so it doesn't like that. Alright, so that might not work for the pointer. So it'll have to be. I'll just comment it out for now. The high one doesn't work, but it is commented out. Let's look at the other one. So I think I can get those right. So aggregate value we use where that was. Yeah, so if I do the same thing. So what if I do int64t? Let's see. No, equals 64t a dot word. And cast it to a word. Okay, I guess that doesn't work. It was working though, so I don't know what. Alright, what does this mean exactly? Can I look at that? Okay, so it doesn't like that. It was working with the float. Or no, with the int. Okay, so maybe this won't work. If I make this as float, then it will work, right? Yeah. Okay. So I don't know. Alright, so that might not work. So I might have to undo all that stuff that I did. It was working though, so I don't know what happened. I must not have actually saved. Okay, let's see. Alright, so I guess I'll just have to make let's go back. Into float. We'll leave that one there. So I don't know that we really need this one because character is basically just an int, so we can probably treat it like that. Could we do that? Maybe we'll make int to character. And yeah, we'll just pass that. Okay. Yeah, this is this, but that is good. Okay. We can try that. So I'm gonna have to change all the instructions back now. Try to leave the this one, but this one needs to be float to int, float, and into character. Here. Yeah, so int to float to int, and into character. Alright, so that way you could cast from a float to an integer, then to a character. So you have that. So we don't have like casting to a void pointer right now. So we need that for probably all the different types of pointers. Well, I don't know. So I'll think about that. That's a bit higher level. Lower level. Okay, let's go here. That's the wrong one. Let's see. Has a not see. That's what I want. And let's just get right here. I need to change the name of these. Float to int and into character. Okay. Does not compile, so excess elements. Why is that? Oh shoot, because I did not add into the into here, I need to add the type for it. Type E and then type into character. Yeah. Okay. Okay. So now it should work. Yes. Yes, indeed. Okay. So let's try do something here. I don't remember what I was doing exactly. Yeah. So we can convert it to that, and then what was the? Oh yeah. So then when we were doing stuff with memory, so I have that in here. Yeah. So we don't know that it's a float, so we need to do. We can call into float, and into float, and then it's the proper type. So if I like, it knows what type it is, right? I heard how we know that's in. Okay, so it didn't work. Hmm. Why? Hmm. We need one that just changes the type. Like, doesn't change the value. Yeah, so this is for actually casting. We need one just to change the type. So just, yeah. So that's more of what I need. Like, it doesn't cast anything. But instead it changes type. Like, so if it's type or it'll just, here, I can show what I mean. So let's open .c. That's really more what I was thinking. .h, actually. So let's try that. What do we want for that? So that's for actually casting, right? So if you have an integer cast it to a float, we need a way to just change the type of it. So how would that be called, let's do cast f, right? Cast I. It's cast c. It's not really casting, but I'm gonna call it that anyway, and I'll change the name later. Cast b. Okay, cast b. Okay, so we need all those, and I'll implement them in the elixir first of all. So after all of these, so cast E, cast F, cast and I know, so we have cast I, so then we'll have cast U as well for unsigned. Once I get to that, cast C and cast P. Okay, and then we need to add it to here as well. Cast E, cast F, cast C, and cast P. Okay, this one, and then I'll actually implement the instructions. I cast F, cast C, and cast P. Okay, so that will just it's just gonna pop out the value, and then change the type. Well, maybe we don't even have to pop it off. So, okay, so let me make sure it still compiles. All right, so just enumeration is not handled. That's fine. So let's open t.c, and then we'll do this. So actually, I'm going to take a quick break before I do this. Just about 3 minutes, and I will be right back. Okay, I am back. So, Ian Trudell has contributed 250 to the Emacs challenge. Very cool. The first one to contribute to that. Been going on for a few days. I'll probably extend it if it doesn't, you know. Yeah, because I think that'd be fun to do regardless. Okay, so let's implement the instructions. So, yeah, let's go to just this. And so we have a few instructions. I went past it. So, inst, what are they? So, cast I. So I'm gonna probably rename it so that these will be just 2 2C 2I, things like that. I think that would make more sense, but I'll do that later. Cast F, cast C, and then cast V. Okay. Great. And great. Alright, so all we need to do is, so I don't really want to pop it off, so we'll just set the value on the top of the stack. So I think that's machine stack size. I think it's -1. I think we have to do -1. Might not be though. Yeah, I think it is. So dot type equals int type. And then I'll grab this. It's here. It's it here. And here as well. And we'll set it to char type, row type, as well as pointer type. Alright, so that should be pretty much it for that. Okay, so now we can actually modify this property. So hello world.cabin. So what we want to do is cast F, and then cast F, and then we should probably print out the type when we call print. Like, it's just a debug instruction, it's not actually meant to be used. But yeah, I think that would be useful. So it did, wait. No, it printed out as that. I would rather have it, I wanted it to be an, okay, that didn't work. Yeah, so I want it to, oh shoot. It may get messed up. So, hang on, let me look at how we actually read. Let's go to that. Pop it off in the data. Alright, so that's that. And then just to this, we set it to int type. Copy into that. Uh-huh. Okay. Let me modify the print, right? So instance print, we have that. Let's just add the type, right? Do that. We'll do. It's really intended type, but type. And then I'm gonna probably make a function for that. Don't want that though. We'll do this. Okay. And then we'll probably just have like types a dot type like that. Okay. I think that makes sense to do. So I'll just make a function for all, or an array for all the types, right? I'll probably make it the header file. It's right here. So just make types equals, and we'll have int float char pointer reg and top. Okay, so I don't know what top type it is. We have it there. I think that will just that should work. Let's exit out of this. No. Multiple definition of types. Alright, so I can't call it types. I guess we have something else called types. So this would just be stereotypes, right? I'm pretty sure I don't use that, so let's go there and we'll just change that to stereotypes. Okay. Here, try to build it again. Multiple definition of stereotype. Huh? Okay. So maybe it doesn't like it in the header file actually. Let's see. try that. Then I'll just put it in here. There we go. Okay, yeah, so it's just forget about it. So then I actually run it. Then we can see, yeah, so the type is still in. What is that? The cast that might be broken. Right, because we're printing it. Cast that. Why does it only print out once? Right, there is definitely an issue here. So this should call. Just print that call. Just to make sure. Alright, okay, actually, I think the issue is I was calling the wrong one. That's what the issue was. Yeah, so it looks like it does work. I was running the wrong file. That's what happened. That's kind of okay. So it did actually work. Yes, it did work indeed. So it took the element on top of the stack and it changed the type. So if I don't do that, it's still going to print out carbon, but it's the type here is going to be wrong. So I can show that. Don't cast that. Then run it. Yeah, it says the type is int, which is not correct. Okay, so I'm going to change the name of it now. So this will be 2i, 2n. So it might be a bit misleading, so those will probably have to be renamed like cast or something. But this makes more sense. Alright, toy, tough, yeah, sorry. So then I'll change these. Top and top. Okay. And then also in here, there's a few places that we have to change each time we change one. So yeah, we need toy, top. It's not right. Top and top. Okay. Actually, do we already have top? We do have top. Shoot. Is that... No. I don't have its top, though. I do have its top. Wait. Oh, that's the one I just made, though. So, what is top? I don't remember what that is. What is it mapped to? Here? Is it entry point? No. So, native halt. Let me open a new pane here. And go into here, let's go to tasmelixer.h, and let's look at type top. And this is not the one that I just had. So type top, type over count, halt. What? I don't quite get it. Top, count. Okay. I don't know what to do with that. I guess I'll make it 2BP. To just avoid any conflicts. I guess. Kind of weird. I don't know what that's for. I'll need to look into that. Again, I've worked on this quite a while ago, so I don't remember anything. So yeah, so I can change this thing. Okay, this is 2BP. Alright, and then I should come up right here. Alright, so we have 2BP already, so I'll just get rid of that expression. Yeah, okay, so let me go right here. get rid of this entirely. And okay, VP. And then got H. I need to change the name of these. I think this is it. Okay, let's go here and try to compile. Okay, so I have some issues. Redeclaration. Yeah, so I need to got to get rid of that one. So in here I can get rid of this one. What? Oh shoot. That is interesting. I don't know how that happened. It's not good. It's gonna happen again. Cause that's not good. That might have been a problem with Kano. I mean, that's what it was. Yeah. What is that? It's in Malik. Alright. Okay, I guess I'll have to use Vim before that. I don't know what was happening there. I'll need to definitely look into that. But okay. Gotta change the name of it. No, I know it is. Okay. So, we can get rid of this one. There we go. Alright, so now it should actually work. Almost. Excess elements. Yes, I have an extra one. Okay. In here. I have 2 of these. Now it'll work. Okay, and then I can modify the thing over here. And we can do top and top. Compile it. And run it, and it has it properly. Okay, so that's what I want. So I can top and void talk and read instructions, and also some stuff with how the memory. Okay, push that. I should have committed earlier, but I forgot to. Okay, build. Okay, so some of the name is a little weird, and I'll have to work on it. What else do we have? So, come right to the memory. And let me actually go to push stir. Go there. What do we have here? Yes, we just append to the memory. So, yeah, we'll push that as point. So that's all good. All good. Yes, we need a way to free memory, right? So we have memory, which maybe I should change memory to Alec. Would that be better? I'll probably do that. I think that could be good. Yeah, I think that makes sense. So let's modify here. So we'll have Alec and then maybe just Dealloc. Alec and Dealloc instead of free. Where's memory? Right here. Change it to Alec. Did not work. And it's Dealloc. So we'll have both of those instructions. I'll need to implement them. We'll go here and inst memory. We'll change it to Alec. And inst Dealloc. Memory. We'll change that to Alec. And I'll implement the Dealloc soon. Dealloc. Okay. Add some lesser. Let's see. So we'll add this to Alec. We'll add Dealloc. Okay. One more place, I think. H, and we need to add this. Oh, okay. And that should be it. So it should compile. I was gonna say, I didn't even say. Oh yeah, because I added. Oh, that's not what I was gonna say. I was gonna say, not handling the switch, but I forgot that I implemented that. So let's go to TASM, and we need to change memory to Outlook, which is with that. Oh yeah, that's not okay. So it should compile. Yeah, and it still works all the same. So, so how's that gonna work? So, basically just gonna remove elements from the memory. We can't just pass a pointer though, because we don't know how large the segment is. Yeah, so I guess we'll just pass the size, the pointer, and the size. So the size will go on top. So yeah, data, data equals pop machine, and then we'll have size equals pop machine, and then we need to check the values like this. All right, so if size outward dot as that's not what I want. Size dot type not equal its type. We have an issue. Let's see. Okay. And then this is pointer data type. It's not equal pointer type. So actually, that's the wrong order, so I'm going to change it. That's okay. Let's see. Expected pointer. So I'll just grab this one and move it up here. So I guess I got something up. What? Alright, I think it. I don't know where I'm gonna stop here. Alright. We'll try this. There we go. I forgot that if you delete it in visual mode like that, then it does not make it at the current moment. Okay, so expected int, that's all good. So then we're gonna make the actual pointer itself. Pointer equals pointer data dot word dot add pointer. Pointer, where it is. So we have the pointer, and then we need to just deallocate. So do we? Yeah, the pointer is where we're gonna be, and we'll just iterate through that many times. So for 0 while I is less than size dot word dot as int plus. We're going to have to cast it to the size side. Let's actually we need to check as well that the size dot word as int is less than 0, then there we go. Then we can iterate over it. Okay. Alright. And we need to just remove it. So I guess we'll just set it to 0, and then we just need to shift the array left by that amount. Do we even have to set it to 0? Because if we shift it left, we'll just overwrite it. Yeah, so I think that's fine. So let's just and just call it, let's make like a shift that's the machine, and then also the amount, so the size. So let's implement this. Let's put it up here. Void shift memory left, so it takes the machine as well as the size. Okay, so then we'll just iterate over. Let's so we need the machine memory starting at the side actually. Well, no, starting at we need the starting point. That's right. So how do I want to do that? Yeah, okay, so we'll do starting point. So then we take the starting point and we subtract the memory, the beginning of the memory. Then we have the starting point, right? So actually I'll make this the starting point. This will be the pointer. Equals pointer minus machine memory data. So that'll be the size. So we'll start there. Y is less than, let's check if y plus starting is greater than machine memory count. Then we need to just print error. Corner next out of that. Okay, something like that. Then we'll iterate over it. Yeah, starting from there, and we need to go to 7 plus size. And we want to set machine memory data by machine memory data by plus 1. Alright. Like that. So is that gonna work? So let's say we have 1, 2, 3, right? And we start here. So we set it to 2, then 3, and then this one, it has to be just empty. When it comes empty. So that shifted from that starting point. Let me make a 1 because that'll easier to think about. Okay, so say we start here. So we set it to 4, then 5, then 6, and then we have the extra 1. So do we have to do -1 here? Or do we not? So let's see. Let me undo all that. So the size, the starting point is here. So that's just 2, right? And the size is 1, 2, 3, 4, right? So we have 4. I think we have to do -1. But we can change it later. And then we need to set machine memory data I. Actually, we need to then also okay, I did this wrong. We don't want to do it based on the size. We want to do it that many times. Yeah. So I'll need to change that. So let's see. No, let me do it. Size is really amount. Not so much size. So I'll leave that for now. But then we want to do it's less than machine memory. And then you can check if machine if starting is greater than its address. Okay. We'll do or amount is greater than machine memory count. Then we don't have enough, right? So we start starting, and we go to that, and we set I equal to that. We want to do this amount of times. So I guess I'll just do this. This might not be right, but I will try it out. The indentation got very weird. There we go. Okay. Something that does the same thing, and we need to set it to that. Machine memory data. Well, we can just actually decrement the count, right? -1. So it'll be 1 less at the end of this. Okay. So that space is still there, but it's gone. Like we deallocated. So I think that's it. It's not gonna compile because I have like 8 things that I have to change. And that's a lot of stuff. Memory is on a pointer, so it's going to be dot. For all of them. Okay, and then we have okay, so it doesn't like that. I just cast this to avoid pointer because it's just a pointer, right? So keep it fine. Yeah, so I need to add more arguments to there. So that's 545. That's the pointer as well. Word.editing. Okay, so it compiles. I'm not sure if it'll work, but we'll try it. Let's get rid of this stuff. So we'll push 8 out. Then we'll push 8 1 and out. And okay, so we have I'll put it up here. we have pointers at the top, right? So we have pointer 1 and pointer 2. Um, so I want to try to free this one. So what we'll do is we'll write data to this one, to that point. Well, that point is gonna become outdated though if we free this one. So I didn't even consider that. Shoot. That is a problem. Yeah. Yeah, because then that pointer is invalid. So this isn't gonna work at all. Okay. So I'll need to think about a better way to do this. Maybe it's just gonna have to look like a stack where you can only free from the top of the stack, you know? Yeah. So it's basically gonna be like a stack-based allocator, that kind of thing. Yeah. Okay, so dealloc, I had to completely change it then. So we'll just basically pop from the stack is what it's gonna do. So that's gonna be even easier, basically. Pop memory. Yeah, we don't need the pointer, so I can get rid of that. I should have thought of that because I just didn't even think of that. The size. This will just be the amount we free. So we'll just that's machine and size. I will rename this memory, machine, and size. This can be called size. Okay. Don't need that. Yeah, that cannot be greater than that. And then we'll just basically set machine memory dot count and single size. And that's it, pretty much. I could set it to 0 as well. And set machine memory data plus size. Wait, that's not what I want to set. So I want count dot data plus machine memory dot count minus size. So that would take the total size minus that, and that is the starting point. Yeah, 0 and then size. Okay, so I think that would work. That would just set 0. Like, we don't really have to do that, but then we'll have some better things. So that means that on the place that needs to be a size, and also this needs a semicolon. Okay. That size is not valid. Need to be signed by word.x in. Okay. Build it again. Compiles. Okay, so yeah, dealloc works more as popping off the stack. So yeah, we can allocate these. So let's actually write to it as well. So we'll push I think we push the data and then the size. I don't remember exactly, but I think that's what it is. So let's push let's use integers so it's easier. So 128. And push 8 and then write. And then here we'll do this and we'll push we'll push 1, 2, 3, push 8 and write. First of all, though, we need to duplicate these. And do. So this ends up, we'll have 2 pointers on the stack, and we'll have 128, we'll have 8, and write consumes all 3 of these. So then we have 1 pointer. Then we push 8, and we allocate it, so then we get another pointer there, and we get another one. 1, 2, 3, 8, write consumes 3 of these, and then, yeah, so we have both the pointers on the stack. So, then we can read from it as well. But first I'd like to just dealloc, right? So in this top pointer becomes invalid. So, we shouldn't be able to do anything with it. So then if I swap, so I don't want to get rid of it, but I want to swap it, and then I'll test some stuff with it. Then I want to push 8 and read, and then just print it. That should print the integer. So I think I did everything right. Okay. It doesn't say where. Yeah, because it was during runtime. So that is, where would that be? It's probably with the read. So I probably forgot something. Read. Let's go get it. Size pointer. So where's the pointer on the top? What's the Emacs challenge? I will. Basically, it says. I think it says. yeah, I'll start using Emacs as my permanent editor, so like all the stuff, just for like a week or whatever. So I'll like actually use it. I'll learn keybinds and all that stuff. That's basically just what it is. And I have never really used Emacs, so I'd have to learn it. Yeah, that's basically just what it is. Okay, so expected int, so it could be here. Ed challenge one. That's an interesting one. I've never used Ed. That'd probably be a bit harder than the Emacs one, right? Alex, dude. You actually used Ed for a bit, and how was it? Science and data. Okay. Size data and then a pointer, yeah. So the pointer goes on the bottom. Size data, yes, that's right. Maybe from the DL. Size. Yes, we need to push the amount to the out. So we'll push 8 and deallocate 8. Okay, then we have 128 on top. If you thought Vim has a steep learning curve, then you're not ready. So it's that bad. It's just line based, right? Isn't it? Like there's not multiple lines, it's just a single one at a time, right? Or is that not how it is? I've not looked into it at all, so I don't know. Okay, so that works. So we got 128. So it did actually, well, we swapped it. So what if we don't swap? Then it's just going to be 0, right? Yeah, 0. So that worked, actually. Made to run on teletypes, yeah. Point fit, so we can just drop it. So usually you'll drop it, I guess. Okay. What type of family label? Huh? Team 5. It's drop, not an instruction. It's pop, right? Yeah. Okay. So that works. Very cool. They wrote units on it. It's not that bad. Okay. Would it be a fun challenge, though? Oh, yes? Okay. I might actually try that after the Emacs one. That could be fun. I don't even know if I have it installed. I do have it installed. Okay, that makes sense, actually. Line-oriented editor. Yeah. I want to look at... let's run it. Let's run it. A little slow. Okay, I don't know how to use it. Yeah, I'm definitely gonna try that out sometime. By default on most Unix-based systems, yes. That makes sense. And it's the standard editor, right? So I can give it a this. I don't know what that was for. Ed file. Okay. I'll use it here. So I'll modify this one. So ed okay. 223. Then do A to append. Okay. And then go back to command. Okay. Exit. Okay, let's look at it. If you don't. Yeah. Oh, you have to save it properly, actually, instead of just quitting. Is the number of bytes. Okay, that makes sense. Let me try that again. Save. Didn't save W, okay. You quit like that. Okay, cool. Let's look at it then. Yeah, there we go. Pretty cool, pretty cool. Okay. Can you, like, look at the contents, or how do you do that? Back to that. Okay, so we did it. Put stuff here. Comma and okay. Right. Ooh, okay, I see. All right. And then how do you I don't understand why. Okay, it's easier to read it. So how do you like modify a certain line then? Macro for all lines. Okay. I guess I could look it up, but uh, rather ask. Yes, like say I wanted to modify line. Oh shoot! Whoops, that's not good. Line like 22 or something. Change. Yeah, change. Like change this line to read space 15, something like that. You know. 22C. Okay. There we go. Okay. I see. That makes sense. Hmm. That would probably not be. Would be kind of hard, probably. Not necessarily hard, but just tedious. That's a better word for it. Can use S too to save or for what? Oh, okay. I see. 20. Okay, let's try that. Uh, read 18. Okay. Cool, cool. Choose for reject search and replace across the range. Alright. Alright, I see. Makes sense. I'll have to remember though. This could. What is this? Oh, yeah, it's like. Okay. Uh huh. Unless you want shell commands, alright. Just like in VI, yeah. He copies the contents of a file into the buffer. Cool. It's R. Okay. They're close to each other. On the keyboard. This as well. And this. I think that's it. Uh-huh. Okay. Pretty cool. Pretty cool. I actually should probably commit some. So, which? What's the invite? Okay. Mm, I'm getting pretty close. Have most of the features implemented that I want, at least to start. So, right. So for this, excluding like this part, I'll get to that. We have pretty much what we need for all this stuff. It's just like what a simple program would look like. Mm. And it's also the reason when you have grep and set. Oh shoot! I didn't even realize that. Like said is SN. Yeah, it is has been pretty influential. Okay, yeah. So next stream, I don't know. I'll think about it. Uh, said is a standalone S command from ed. Okay, I see. That makes sense. And grep is another part from said or from ed. I haven't looked at any of that stuff, so I did not know that. That's pretty cool. Mm. Grep is named from the ed command. G. Oh, okay. I see. I did not know that. That's pretty cool. Shoot. It looks better. I like that. Better. Yes, something else I would like to change. Got VI out of ed. Okay. And VI, Vim, Neovim. Yeah. Yes, yes, yes. Familiar with the stages of VI for sure. Yeah. So I want to change the strings. Let's see. So that is. Let's see. String stack. I want it to be. Just so I'll probably bring in the actual library, but for now I'll just do this. Okay. String view stack. Then we're gonna have to change replace. So I'll probably go through the compilers and see. Edmaster lets you edit your code without even seeing it. Yes, that's pretty cool. That's a cool idea. Yeah, I'm definitely gonna have to do an ed challenge at some point. Be a string stirred. I'm gonna do the string size. We can do stir.len data. Stir.len. Okay, that should work. And then I think also we need that. Yeah, so we have this. So then we don't need the stir size. Actually, I think I could just write the string because the length will go first anyway. Just write the whole thing. But then I don't have that size. Yeah, so I can't quite do that. So I have to do something. That's fine. So I'll probably make a variable for this. Stir equals that. Let's use that here. Stir. Okay, like that. Oh, and that should write it. We don't need this anymore. Then here, so I still need this. So this can function the same. See ya. Have a good one. Have a good one. Mm. So we have to read both of these. Like that. I'll probably do the same thing. Machine. There's that. Like that. Yes. I'll take a pointer to it. So we can actually modify it. That's not gonna work, so I'll have to leave that the same. Okay. Then this can be stir arrow line. As well. Stir data, and that's fine. Okay. This actually needs to be stir data. Stir data like that, yeah. Okay. That should be pretty much it for that. Then we have a few other places. Stir is not used. Okay, there you go. Stir stack. Spell it wrong. Okay. Stir lamp. Oh shoot. That needs to be a pointer. Which stir? Let's look at that. So how's that implemented? What is this? Okay. I mean, we can just get rid of that. Get rid of all of these. Yeah, because we don't need that. We don't need this either. Stir, yeah, we don't need that either. We don't do this one. Used, okay. Okay. Yeah, then we don't need this function at all. Okay, string view. 31. We don't need a pop stir either. Oops. Stir. Yeah. That was it. Save. Okay. So that is in test not seen. So yeah, we have issues with that. So we need to modify. Where is that at? It is generate instructions. That's actually in here. Oops. Nope. There we go. I keep pressing the wrong key. Alright, so this is not in here. So where is it? It's in here. Okay, so this needs to be a string. Okay, almost compiles. Still didn't work. Huh. Okay, because I need to modify the header file as well. String. Okay. Still don't work. Huh? Oh shoot. Yeah, it doesn't need to be that. That's one. Like that. There we go. Okay, so incompatible types, that's in here, so 145. Yeah, so now, string size is that. Data is that. Into the dot data, and we need to set the len as well. Static size. Len equals the size. So I can make that like that, and that should compile. Okay, so it does compile. Let me make sure it still works. Let me modify the hello world. I'm. I had something again. So let's just register world. Push 1 and native lens. That's the right, and that should right. Okay, so it still seems to work. So I will commit that. Change stack to be because then that way we have the size as well. Okay. And by default, they're null terminated and size, which isn't great. That's how it is. So I'll probably change it so it's size by default, but then if you put C, it will become null terminated as well. Like, you know, like that C, or maybe C goes first, I'm not sure. I have to think about it. But something like that, you know? Some symbol that shows that it's different. I think I made a mistake though. Maybe not. Yeah, I guess not. Okay, so yeah, we seem to be pretty good. So we can write and read from them, and I can look at it. If we hex them, I can go into here. Let's see. Oh, we got 10. Let's do hex edit. And we can take a look. So here's the string, right? You can see it very clearly right here. And here's the data for it. So the size is 8 bytes before, so it's 0f, so that's 15. That's the size. Which makes sense. And then we have the whole string here. And at the end, I suppose this is the null termination character. And then this is some other size and instruction stuff. Let's see what. Isn't there a new line? Did I not put it in the line? Oh, that's not one. Okay. Yeah. Oh, wait. Okay, test. There is a new one, but it did not read that. But it did, because it printed a new one. So why is it not? Oh shoot, this is the new one. That is, because that's 10. Okay. Then this is the null termination. That makes sense. Okay. I thought it was the exclamation point, because I was looking at it wrong. Okay, I see. So that checks out. Checks out. Okay. Yes, that's what the assembly looks like right now. Yes, we have most of what we need then. Right. Just thinking now. So most like the syscalls and C functions expect it to be null terminated, these strings. But it is easier to at least read them if they are size, you know? So yeah, I think I'll do what I was talking about, where it's always gonna be sized because it's just easier to handle it that way. But then let me ask if I can hear. In this one, so if we put like this, then it will be null terminated as well. I don't know if it'll go there, or maybe it could just be there. Something like that. Just something to show that it's C string rather than a size string, if that makes any sense. So that's really just on the level of the assembly though, and it doesn't make any other difference to the, I'm not going to add it now. It doesn't make any other difference to the actual virtual machine though. Alright, so that's pretty much it. I got done what I wanted to get done today. So tomorrow, or next stream at least, I'm probably tomorrow. I am going to, well, so I'm gonna think about it and do some research over the next stream. But I think we're pretty much good in terms of the virtual machine to start building the programming language, the scripting language on top of it. So yeah, this is what it's gonna look like. Or something like this. It's not final yet. I'm gonna think about that as well. And we probably can just have an end. We don't need a specific thing like that. So we'll just have end, which ends just a block, right? So it basically functions like brackets. And like this opens one, so we call fun. And then we have the identifier after as well. And then if would also open one, so it's basically the same as brackets. Yeah, it's just gonna look something like that. Yeah, so probably this will be the first thing. The first thing that we implement. So right, it's going to be like a built-in syscall, right? So it's not going to have brackets around it. But when you call functions regularly, it's going to look like that. But this isn't going to be a function. It's going to be a built-in thing. So yeah, that's what it'll look like. And what this will do is it will write to standard out, essentially. So it's just like a print function, essentially. Yeah, so that will probably be the next stream, unless I think of something else that I really need to implement. That will be about it. So change the... Alright, yeah, so that is about it. Let's make sure it all worked. And also I need to write good documentation for this, like on all of the instructions and stuff. Also, this is outdated. So I'll need to do that. But not now. So that's gonna be it for today. So thank you for watching, and I'll see you next time. Bye.